Hello everyone, welcome to the today's class. In today's session, we are going to solve the questions which were asked in GATE paper of 2023 of Aerospace Engineering. Just to give you a brief idea about the total number of questions asked and the difficulty level. So there were total 13 marks questions were asked in this paper, out of which 5 questions were for 1 mark and 4 questions were asked for 2 marks. So let's try to solve them one by one. The first 5 questions will be for 1 marks and later there will be 2 mark questions. Starting with the first question, it was question number 11 in the paper. The direction in which scalar field phi has the largest rate of change at any point with a position vector r is equal to xi plus yj plus zk is the same as that of vector. So whenever we have a scalar field phi in xyz direction, then the gradient of this scalar will be defined as the largest rate of change. Okay, so the largest rate of change is defined by gradient of phi. If phi is scalar field, then gradient of phi denotes the largest rate of change. And what is gradient of phi? It's del phi. Okay, so hence question number, hence the option A is correct for this question. Coming towards next question, question number 12. If a monotic and a continuous function y is equal to f of x has only one root in the interval x1 to x2, then, okay, so it is given that we have an interval starting from x1 till x2 and we have only one root in this interval. The meaning that we have only one root means this function will cross the x-axis only once. So maybe let's say f of x1 is negative and f of x2 is, let's say, positive, and somewhere like this it is crossing, and that is the solution, or that is the root of this function. Or it can be vice versa, that f of x1 will be positive and f of x2 will be negative. So in order to have only one root in the interval x1 to x2, the function has to cross the x-axis within this interval x1 to x2 only once. Okay, and hence on either side we'll get a negative function, and on other side we'll get the positive function. So if f of x1 is negative and f of x2 is positive, their multiplication will be less than 0. Similarly, maybe if f of x2 is negative and f of x1 is positive, in that case also their multiplication is less than 0, right? So option C should be correct in this case, that the functions will have opposite signs, so their multiplication will be less than 0. Yeah. Coming towards next question. Yeah. Consider a one-dimensional wave equation. Dou u by dou t plus dou u by dou x equal to 0, and x is varying from minus infinity to plus infinity. T is greater than or equal to 0. For initial condition u of x comma 0 equal to e to the power minus x square, the solution at t is equal to 1 is. Okay. Let me give you one brief idea about the one-dimensional wave equation. So a general equation looks something like this: aux plus buy equal to 0. The meaning of this is a times dou u by dou x plus b times dou u by dou y equal to 0. Suppose if we have this kind of, let's say, equation, right? If we have this kind of equation, then the solution of it will be written as u equal to f of bx minus ay. Okay, suppose if we have an equation in this form, then its solution is in this form, that is u equal to f of bx minus ay. So if I look into the current question is dou u by dou x plus dou u by dou t equal to 0. Here the value of a and b is 1 because we don't have any coefficients of the derivatives, so their values are 1. So directly we can say the u should be here u of x comma t should be equal to f of x minus t, for example. Okay. And they have also given us the initial condition. What is the initial condition? Whenever the value of t is equal to 0, the value of the function is e to the power minus x square. So u of x comma 0 is equal to e to the power minus x square. So here t is 0, that is given, and we are supposed to calculate what is the value of u at x comma 1. Okay. So in general, if you assume it is t, and considering the equation number 1, the function should look something like this: e to the power minus, in place of x you should write x minus t whole square. Okay. And so the value of t is 1, it is given, and at that instant we are supposed to calculate the value of u. So u should be equal to e to the power minus of x minus 1 whole square. Okay. And it's matching with the option number A, hence option A is correct in this case. Okay. Coming towards next question. This is again the 1 mark question. Which of the following statements is an or are true with respect to eigenvalues and eigen vectors of a matrix? First statement is sum of eigenvalues of matrix is equal to the sum of element of the principal diagonal. Yes, it is correct, because suppose if we have a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. And lambda 1, lambda 2, lambda 3 are the eigenvalues. Then sum of the eigenvalues, lambda 1 plus lambda 2 plus lambda 3, should be equal to the trace of the matrix. And what is trace here? Sum of the elements of principal diagonal, A11 plus A22 plus A33. Okay. And that's why this statement is correct. Either you can say it as a sum of elements of principal diagonal or trace of a matrix. Okay. And second statement is, if lambda is eigenvalue of matrix A, then 1 upon lambda is always eigenvalue of its transpose. It is not correct, because we know we write Ax equal to lambda x. Okay. So where x is an eigenvector, A is an given matrix, and lambda is the eigenvalue. So whatever operation we are doing for A, same operation will be applicable for lambda. Eigenvalue of A square will be lambda square. Eigenvalue of A inverse, A raised to the power minus 1, should be equal to lambda raised to the power minus 1. So 1 upon lambda is an eigenvalue for A inverse. Okay. So it is not the eigenvalue of A transpose. So this statement is incorrect here. And coming towards the next statement, if lambda is the eigenvalue of an orthogonal matrix A, then 1 upon lambda is also an eigenvalue of A. Okay, so what is an orthogonal matrix? Orthogonal matrix is that E transpose equal to A inverse, right? In that case, we call it as an orthogonal matrix. So if lambda is an eigenvalue of orthogonal matrix A, then 1 upon lambda is also an eigenvalue of A. So that is incorrect. So we will say that rather than, let's say, orthogonal, if they might have said symmetric matrix, still the answer will be wrong. But either of this, if they say, let's say 1 upon lambda is eigenvalue of A inverse, or 1 upon lambda is eigenvalue of A transpose, then it would have been a correct statement. But what they said is 1 upon lambda is also an eigenvalue of A. So this is incorrect. Either it should be A inverse or A transpose. I hope you understood. And the last statement is, if a matrix N has distinct eigenvalues, it has N independent eigenvectors. Yeah, this statement is correct. Whenever we have a matrix with a distinct eigenvalues, all these eigenvalues will, corresponding to these eigenvalues, will have independent eigenvectors. So for this question, options A and D are correct. Okay, coming towards next question, question number 30. The system of equation is given to us as a non-trivial solution for the alpha value, and that alpha value we have to calculate. What is the meaning of non-trivial solution? Maybe an infinite solution, right? So non-trivial solution is when we'll get a determinant of the given matrix is 0. So basically we have to rewrite these equations, system of equation, in the matrix form and take a determinant and equate it to 0. So we can write the system of equation in the form of matrix like this: 1 minus 2 alpha, 2 1 minus 4, 1 minus 1 1, x y and z equal to 0 0 0, right? So this is our matrix A, which is coefficient of matrix. And if we take a determinant of this coefficient matrix, and for a non-trivial solution, it has to be 0. Okay. Suppose if we have a matrix A, Ax equal to 0, this is our format of homogeneous system of equation. If determinant is non-zero and determinant is 0, if determinant is non-zero, you will get a unique solution or a trivial solution. And if it is determinant is equal to 0, you will get an infinite number of solution or non-trivial solution. Okay, so in this case, determinant has to be equal to 0, and let's do that in order to get the alpha value. 1 minus 2 alpha, 2 1 minus 4, 1 minus 1 and 1. Take a determinant and equate it to 0. So what you will get is 1 into 1 minus 4 plus 2 into 2 plus 4 plus alpha into minus 2 minus 1 equal to 0. So this is 4 minus 1 minus 4 is minus 3, plus 2 plus 4 is 6. 6 into 2 is 12, plus minus 3 alpha equal to 0. 12 minus 3 is 9. 9 is equal to 3 alpha. So alpha has to be equal to 3. Okay. So the correct answer in this case is 3. Okay. And they're asking in integer, so you should just write 3. Next question. Question number 36. Okay, it's a 2-mark question. What is asked here is, given a function y equal to x plus 3, x minus 2, for the value of x in the range of -4 to 4, what is the value of x at which the function is minimum? Okay, so we know that this given function is in the form of single variable, and whenever a function is in the form of only one variable, only one independent variable, we have to differentiate it and equate it to 0. So y of x equal to x plus 3, x minus 2 can be written as x square plus 3x minus 2x minus 6. So y of x is simply written as x square plus x minus 6. Okay, what is y dash of x? Is 2x plus 1. Okay, and if we equate it to 0, what is the value of x we'll get? X is equal to -1/2. So at least we got the value of x at which a function is either minimum or maximum. Let's check whether it's a minimum or maximum. So in order to check that, we again.
Hi sir, there is some concern in question number 29.
Yes, okay.
Someone was claiming on YouTube chat box. You can see, sir.
Okay, sir. I'll
yeah,
check
please
it.
continue this. After that, you can look into that.
Yes,
Thank
yes.
you.
Okay. Coming towards this question again, x is equal to -1/2, and if we differentiate it again, y double dash of x, what we'll get is only 2, right? And whenever double differentiation is greater than 0, it means we'll get a minima there, minimum value. Okay, so at x is equal to -1/2, we should be getting a minimum value. Hence, answer option B is correct in this case. That is, x is equal to -1/2. Okay, yeah. So coming towards question number 29. Yeah, so what is the doubt here? Take an identity matrix as an example. So Abhishek, these statements are in general. They are not, let's say, constrained or specified only for the identity matrix. So it can be any general matrix, and so you cannot just let's say use an identity matrix as an example and make a general statement out of it. Yep. So let me just try to help you in understanding this concept of, especially because I removed these two options of eigenvectors, option B and C. I'll try to explain it once again. So we know characteristics equation of the matrix is A minus determinant of A minus lambda equal to 0, and then A minus lambda, and then in order to get the eigenvectors, we multiply with x, right? So A minus lambda into x equal to 0, and ultimately what we say is Ax is equal to Ax minus lambda x equal to, or Ax minus lambda x equal to 0, or Ax is equal to lambda x, we say, right? So this is the equation. We get it from the characteristics equation, and what we say is, if you take a given matrix and if you multiply with eigenvector, okay, you will get the same answer if you take the eigenvalue and multiply it with the eigenvector. Okay, so whatever operation you will perform on A now, so here x is common, that is eigenvector is common on both the sides. So whatever operation you perform on A, the same has to be performed on lambda. Okay, suppose if I want to calculate the eigenvalue of A square, then it will look something like this: A square x equal to lambda square x. Okay, so if eigenvalue of A is 2 and 3, then eigenvalue of A square matrix should be 4 and 9. Okay, similarly, if eigenvalue of matrix A is suppose 2 and 3, then eigenvalue of A inverse has to be equal to 1 by 2 and 1 by 3. Okay, so this is for the inverse, not for the transpose. Okay, so that is the reason we have neglected or we have removed this option B here. Okay, so that's why this option is wrong, and similarly option C is wrong, because in orthogonal matrix A transpose is equal to A inverse, but they have just mentioned A here, not the A transpose and A inverse. So that is the reason I have removed this also. Okay, I hope you got the answer here. Coming towards the next question, question number 42. Okay, this question is again 2-mark question, little bit lengthy. Let's try to solve this. So I'll take this question on the next slide because it is a little bigger. We have dy by dx plus ay is equal to sine of omega x. Dy by dx plus ay is equal to sine of omega x. Okay, where a and omega are the constants. They have given at y is equal to 1, and sorry, they have given at x equal to 0, y is equal to 1. Y at x is equal to 0 is 1. This is given data, and we have to select out of this given statement which are all correct. Okay, when x tends to infinity, what will happen when x tends to infinity? So you can either solve this equation by using the linear equation, or you can solve it by using CF plus PI method as well. Okay, so let's try to solve it with the CF plus PI method. CF will be in this case, if I write this as d plus a times y equal to sine of omega x, so I can write d plus a equal to 0. We can treat d plus a as an algebraic equation, and you'll get the value of d as minus a. Hence, the CF in this part is C1 e to the power minus ax. Okay. Coming towards the PI part, PI will be equal to 1 upon d plus a operating on sine of omega x. Okay. But we cannot operate here d plus a. So because whenever we have sine and cosine function on the right hand side, we replace d square with a minus of omega square in this case. So I have to multiply and divide this equation with a d minus a. Okay, in order to get the d square term in the denominator. So d minus a we will get in the numerator, and d square minus a square will get in the denominator. And you have to operate this function on sine of omega x. So when we operate this function on sine of omega x, what will happen is d minus a will remain as it is. It will operate on so first of all, here you will replace d square with minus omega square. Okay, so I'll write the denominator first, 1 upon minus omega square minus a square as it is, and in the numerator you will operate d minus a on the sine of omega x. The meaning of d is what? Differentiation. So differentiation of sine of omega x is omega times cos of omega x. Okay, and minus sign as it is, a into sine of omega x. Okay, so this is the answer for pi. Now the total solution we know is CF plus pi. So y can be written as C1 e to the power minus ax plus pi. Okay, so it should be plus. If you take a negative sign common from the denominator and the numerator, you can cancel them out and write a sine of omega x minus omega cos of omega x divided by omega square plus a square. Okay, so this is the simplified or the final solution of the given differential equation. Okay, if it is clear till this, then we just have to what we have to do is we just have to put the options now which are given here and try to get the solution out of it. So let's start with the option A here, or yeah, so maybe not A. Yeah, okay, we can take we can deal with A and B together. So let's try to put A is equal to 0 in this case. Okay, and then we'll get idea about if A is non-zero, what will happen. So if A is 0 in this case, what will happen? And x is tending to infinity. So I'm considering the case at A is equal to 0. Okay, and x is tending to infinity, we know. So C1 e to the power 0x, so it will be e to the power 0 means 1. So we'll have C1, sorry, okay, C1 as it is, plus here this term will become 0 because we sine of omega s we are multiplying with A, so we'll get a 0 answer there, minus omega cos of omega x, that term will remain as it is, divided by omega square. Okay, so this is what we will get. So this omega and omega will get cancelled, so we'll have this term C1 minus cos of omega x divided by omega. Okay, in order to get the C1 value, we don't have the C1 value, so they have given the condition that when x is equal to 0, y is equal to 1. So we will calculate the C1 value in parallel. So y will be equal to 1 when x is equal to 0. So C1 into e to the power 0 is 1 plus sine 0 is 0 minus omega as it is cos 0 is 1 divided by omega square plus a square. So C1 will be equal to 1 plus omega divided by omega square plus a square. Okay, so this is the value of C1. So let me write it here. Y will be equal to 1 plus omega divided by omega square plus a square. Okay, so this is what we will get finally. And yeah, a is 0, so this term we can remove, and here omega and omega square will get cancelled, so we'll have 1 upon omega. So in short, the term will look something like this: 1 plus 1 minus cos of omega x divided by omega. Okay, so this is the term we are getting. So when a is equal to 0, it's not guarantee that we will get y is equal to or y tends to 1, because it is 1 plus some other term. Okay, because we know cos is always lying in between -1 to +1, so we don't know. So at infinity also it can be within this range only, right? So if it is, let's say, -1, then minus minus will become plus, so 2 divided by something omega, so this term will no longer be equal to let's say 1. So that is the reason we can say that here option maybe this option is incorrect. Okay, a is equal to at a is equal to 0, y is tending to 1. Okay, so we can remove it. Also, if you see a is non-zero, then y also cannot be equal to 0. Why? Because you should remove this, because you know there is always one term 1 plus something. Okay, because in C1 we got 1, so 1 plus some other terms will come, and they will not cancel out, even though let's say A is non-zero, right? Because for we will have sine omega x term, we'll have cos omega x term, and they are not always equal, right? So these terms will not cancel out with each other, even if you consider A as non-zero. Okay, so you will have some 1 plus some terms, either positive or negative. So it's not always let's say 0 you will get. So that's why you can remove the option A as well in this. Now coming towards the third and fourth option, okay, that is A is less than 0 and A is greater than 0. So let's try to solve it. Okay, let's say A is greater than 0. Let me write the solution again. The y is equal to C1 e to the power minus ax plus t sine of omega x minus omega cos of omega x divided by omega square plus a square. Okay, let me try to explain this. How can we so simplify this further? Can I write it like this: a divided by omega square plus a square, and here omega divided by omega square plus a square? We can write it like this, right? And if you consider a triangle in which, let's say, a is one side, omega is other side, then under root of a square plus omega square will be the diagonal. Okay, and in that case, let's say if you consider maybe this angle as phi, for example. Okay, so a divided by omega square plus a square, that is base divided by hypotenuse, you can write it as cos phi. So I can simply write it as C1 e to the power minus ax plus cos of phi sine of omega x minus sine of phi cos of omega x. So C1 e to the power minus ax plus sine a cos b minus cos a sine b is sine of a minus b. Okay, so this is the equation. We will get a simplified equation. And now let's put the condition when a is greater than, sorry, as x tends to infinity, and let's say a tends to a is greater than 0. What will be the value of y? So a is greater than 0, so a is a positive number here, right? And x tends to infinity, so e to the power minus infinity is what? 1 upon infinity, right? And 1 upon infinity is 0, so it will be C1 into 0, the first term, plus sine of omega x minus phi. Yep. Yeah, just one more term I forgot to write here is divided by under root of omega square plus a square. Okay, because this is the hypotenuse, not the square of it, right? So it should be like this, under root of omega square plus a square, right? So now how the solution will look like is C1 into 0 plus sine of omega x minus phi divided by under root of omega square minus omega square plus a square. So looking into the option D, so this you can treat as one constant. Can you still write it as a sine of omega x plus or minus c? Okay, yeah, we can write it like this, right? So it's more or less same. B you can consider as this term, constant term, 1 upon under root of omega square plus a square. So let's write it as b sine of omega x minus phi. So I consider phi, they consider it as minus c, so we can also write it like this. Okay, because here the c is an C is still a constant, and you can write it like this, and hence you can say we can write the answer if b and c are the constants. Okay, we can still write the answer in this format: b sine of omega x plus c, right? Hence option D looks correct. Let's see option C is correct or not. So you will still use the same equation, and a is less than 0. Let's try to look into the solution of it. Y is equal to c1 into if you put e to the power infinity, so you will get c1 into e to the power. A is a negative number now, minus minus will become plus, and x is tending towards infinity, so you should get here c1 into e to the power infinity, right? And so, or basically c1 e to the power ax, right? Because an x is tending to infinity, will consider it in the next step. So as of now, I'll write it as c to the power ax, because a is negative and minus minus will become plus omega 1 divided by under root of omega square plus a square sine of omega x minus phi. Okay, so this is how the solution will look like. But if you look into this term, as x is tending towards infinity, what will happen? If x goes on increasing, it will become e to the power 2a, e to the power 8a, e to the power 100a, e to the power 1000a, e to the power 10,000a, and so on. So this term will get bigger and bigger and bigger, right? What about this term? This term is always in between -1 to +1, because it's a sine term, right? So, and again you are dividing it with some term. So ultimately this secondary term, as x tends to infinity, will become negligible, and first term here takes the dominance. So y will, as x tends to infinity, we can say y is equal to some constant, maybe let's say a e to the power ax. Okay, and let's look into the options. Yeah, so it is a e to the power ax. Okay, and because a is negative, and we already have minus a there, so minus minus will become plus. So this looks correct answer. So option C is also correct in this case. Hence you should have chosen option C and D here. Okay, any doubts? Okay, if no doubt, we'll proceed further. The next question is yeah, about the again vectors. We got A, B, C, 3 different vectors, and which of the following statements are true? They're asking us. So the first is A, B, C, whether they are coplanar or not, that we have to check. The second one is a scalar triple point function of vectors A, B, C is 0. Okay. And the next one is about whether A and B are perpendicular. And the last option is C is parallel to A cross B. Okay. So the option A and B are similar. Okay. Because if the 3 vectors in a 3D space, let's say, are there, and they are coplanar, means what? They are coplanar only when the scalar triple product is 0. Okay, so I'll write in the next slide. In 3D space, if the 3 vectors have scalar triple product is 0. Okay, then these three vectors are coplanar. Vectors are coplanar. Okay, so yeah, let's try to calculate the, suppose we got vector x, vector y, and vector z, then x dot y cross z is nothing but the scalar triple product. Okay, and now you have to check whether this is 0 or not. So if option B is right, then option A is also right. Okay, I hope you understood here. So let's try to calculate the scalar triple product of A, B, C. 9, 5, and 2. So first B cross C you have to do, and then take a dot product with A. Okay. So B cross C, let's do it here itself. B cross C is what? I, J, K, 11, 4, 1, -7, 14, and -3. Okay. So how the B cross C will look like, and let's make it A with A dot itself, here itself. A dot. A dot B cross C will be equal to A is what? 9i minus 5j plus 2k dot product with output vector of B cross C. Okay, so 9 into 4 multiplied by -3 is -12, and -14, right? -5 into, and here again minus, you'll get a minus j, so this will become plus, and it will be -33 plus 7. Okay, and the third term is 2 into 11 multiplied by 14 plus 28. Okay, so if you solve the first, -12 minus 14 is -26 multiplied by 9. It will become -234. Okay, second term -33 plus 7 is -26 into 5. You will get my -130, and the last term you will get is 364. So basically, when you add them and subtract, you will end up with 0 answer. So it is satisfying the condition that the scalar triple product of the vectors E and B, A, B, and C is 0. So the option B is correct in this case. And what about the option A? That is also correct, because I already told you, if the scalar triple product of the vector is 0, means those vectors are coplanar. Okay, here option A and B are correct. Let's look into the option C and D. So it's about the perpendicular and parallel vector. So what about the perpendicular? A and B are perpendicular, they are saying. When the cross product of let's say let's take a product of these two vectors A and B, and then we can make a conclusion out of it. Yeah, let me write this option A and B on the next slide. 11i and plus 4j plus k, and C is, sorry, A I have to write. This is B and A is 9i minus 5j plus 2k. Okay, and we'll also write C because we know it, we need later. Minus 7i plus 14j minus 3k. Okay, yeah. So what is meaning of perpendicular vectors? When two vectors are perpendicular to each other means the angle between them is 90 degree, right? And the cross product of the vector will be equal to the product of their magnitude, we can say. Okay, let me so let's take the cross product of these two vectors A and B, and then we'll get idea. Yeah, cross product of A and B will be I j k 9 minus 5 and 2 11 4 and 1. Yeah, so what is the cross product here? I just a minute. Just a minute. Yeah, so let's first focus on this. A and B are perpendicular to each other. If A and B are perpendicular to each other means what? Um, the dot product has to be 0. And is it happening? 9 into 11 minus, so let's take A dot B is 9 into 11 minus 5 into 4 plus 2 into 1, and we know that it's not non-zero, so basically we can remove this option C here. Okay, and now we will go to the option D now, whether C is parallel to A cross B or not. Okay, so let's come to that part. A cross B will calculate, and then we'll check about the parallel. So minus 5 8 minus 39 minus j into 9 minus 22 9 minus 22 plus k into 36 plus 55k. Okay, so this is the vector you will get A cross B. And let's check the option C here. Sorry, option D here. And if you take the basically the cross product again with this new vector, you will realize that it won't be 0. Okay, so I have done that calculation. So directly I'm saying that if you take a cross product again with this, you will end up with you will not get 0. So this option also you can neglect here. Hence option A and B is correct in this case. Yeah. Any doubt in this question? Okay. Coming towards next question. Yeah, this is the last question here from the exam. Consider a differential equation x square d2y by dx square plus 4x dy by dx plus 2y equal to 0. And the initial conditions are given when x is equal to 1, y is equal to 0, dy by dx equal to 1. And the value of y at x is equal to 2 is supposed to be calculated. So we know that there's a higher order equation in the Cauchy's form, and here we write x square d2y by dx square as d into d minus 1. Okay, right? So let me write the simplified version of this differential equation. D into d minus 1, let's say, plus 4 times dy. Okay, d into d minus 1 into y plus 4 dy plus 2y equal to 0. And if you take d common, sorry, if you take y common, d into d minus 1 plus 4d, okay, plus 2 times y equal to 0. Okay, so it's a homogeneous differential equation. Only the CF will be the function. D square minus d plus 4d plus 2 equal to 0. So d square plus 3d plus 2 equal to 0 is the algebraic equation we'll get, and d plus 2 and d plus 1 equal to 0 are the roots. So d will be equal to minus 2 and minus 1. Okay, so what we can write is y is equal to c1 e to the power minus 2t plus c2 e to the power minus t. Okay, this is the solution of the given differential equation. Let me write it on the next page. Y is equal to c1 e to the power minus 2t plus c2 e to the power minus t. Okay, and we know here this is in terms of t because we are writing it with the assumption that t is equal to log of x. Okay, and or x is equal to e to the power t assumption, we can say. Okay, so whatever solution you will get here is in the form of t, and now you have to replace that t with the log of x. So y should be written as c1 e to the power minus 2 log of x plus c2 e to the power minus log of x. So this is the solution because our dependent variable is y and independent variable is x. So this should be the solution. And now let's put the given condition in order to get the values of c1 and c2. At x equal to 0, at x equal to 1, y is equal to 0. So 0 will be equal to c1 log 0 is infinity. So or rather than this, we can simply simplify it further as well. Like I can write it as c1 e to the power minus or e to the power log of x raised to the power minus 2, right? So we can directly write it as c1 by x square plus c2 by x. This also you can write. And now if you put the initial condition that at x is equal to 1, y is equal to 0, what we will get is 0 is equal to c1 plus c2. This implies c1 equal to minus c2. This is the first equation. Second equation is differentiation dy by dx is equal to what? Differentiation of 1 upon x square is minus 2 by x cube. So minus 2 c1 by x cube. Differentiation of 1 upon x is minus 1 upon x square. So c2 by x square. And now if you put the initial condition dy by dx equal to 1 at x is equal to 1. Okay, 1 will be equal to minus 2 c1 minus c2. And these are the two equations. Two unknowns are there. You can solve them. Put c1 equal to minus c2. So 1 will be equal to minus minus of 2 times minus C2. So minus minus will become plus C2 minus C2. Okay. So you will get C2 equal to 1. So value of C1 will be equal to minus 1. So the equation number 1 can be written as y is equal to minus 1 upon x square plus 1 upon x. Okay. This is the final solution. What they are asking is the value of y at x is equal to 2. The value of y at x is equal to 2. Y when x is equal to 2 will be equal to minus 1 upon x square. 2 square is what? 4 plus 1 upon 2. Okay, so 1 upon 2 minus 1 upon 4 is 1 upon 4. Okay, that is 0.5 minus 0.25 is 0.25. So 0.25 you should type there. Okay, because you have to round off to the 2 decimal places. 0.25 should be written here. Okay, so let me see if we have any questions on YouTube. Yeah, I think that's all. If you have any other questions, I'll wait for 1 more minute, or otherwise we'll end the session. Okay, that's all for the solution of maths from GATE 2023 paper of Aerospace Engineering. Thank you all for joining this session.